Okay, I'm just going to do a couple of examples involving radicals and the Pythagorean theorem. It turns out that if you have a right triangle, and you can look this up, but if you have a right triangle where the legs are A and B and the hypotenuse is C, then in a right triangle the relationship A squared plus B squared equals C squared is always true. And you could also write this as C equals the square root of A squared plus B squared. So I'm just going to do a couple of problems here that involve the Pythagorean theorem, and then we'll be finished with this section. Okay, so Jason leads a 13-foot ladder against a house. If the base of the ladder is 5 feet from the house, how high is the ladder? Okay, well, I drew a picture over here. Here's the ladder right here leaning against the house, and then here's the house, and then here's the base, and notice the base of the ladder is 5 feet from the house. So in this triangle we have a right triangle because there's a right angle right here, and so we know that if we take 5 squared plus x squared, that has to equal 13 squared. So that's where I get this equation here, 5 squared plus x squared equals 13 squared. Well, then if you square the 5, you get 25 plus x squared equals 169. If you square the 13, you get 169. Well, now if I subtract 25 from both sides, I get x squared equals 144. Now you can solve this equation by applying the square root theorem, and actually you would get x equal plus or minus 12 for the answer, for the math answer, but sometimes the math answer is not the right answer. So here, since the length of the height of the house can't be negative, so we toss out the negative 12 answer and we only use the 12, so that the height of the house is 12 feet. The next question, here's a TV screen, and it tells me that the width of the TV is 18 inches, so that would be 18 for this bottom width right here, and the diagonal is 21 inches. So if you see that diagonal actually creates a right triangle with this. It creates two right triangles, but let's look at the lower one. So I've got one leg is 18, one leg is x, and the hypotenuse is 21. So then that means that 18 squared plus x squared must equal 21 squared, and then 324 would be what 18 squared is, and 21 squared is 441. And now if you subtract 324 from both sides, you get x squared equals 117. And since x can't be negative, then x would be the square root of 117. So x would be the positive square root of 117. And when I put that in the calculator, I actually got about 10.82 feet. Actually, that's not feet. That'd be a big TV, wouldn't it? That should be inches. So 10.82 inches. Okay? All right. Now the last example here says find the distance from home plate to second place on a baseball field if the bases are 60 feet apart. Well, let's say this is home plate right here, and let's say this is second base right here. That's supposed to be a 2. Alright, so second base is here. Alright, now we know the bases, so it's 60 feet from home to first base, and it's 60 feet from first base to second base. And we know that this forms a right triangle, and we're looking for the diagonal, which we'll call x. So we know that 60 squared plus 60 squared must equal x squared. So if 60 squared plus 60 squared must equal x squared, well, that's going to be 3600 plus 3600. So let's add those together, you get 7200. So x squared equals 7200, and then take the square root of that, and so x would equal the square root of 7200. And when I found that with a calculator, I found that the square root of 7200 was almost 86 feet. It's about 85.85 feet. And so that's pretty much all I have there. Just wanted to show you some examples on solving problems that involve the Pythagorean theorem. And they don't really involve a lot of radical work. The radical comes into play when you actually apply square roots to these answers to get the answers. Alright, that completes this entire module over radicals and rational exponents.